Yes,
Like,
yes, I can see this cover slide. That's perfect. Thanks, Linda. I'm going to let you take us through the slides, and I'll just give a quick introduction. So thank you everyone for joining us today in this National Biodiversity Assessment 2025 webinar series. I think this is the fifth in this webinar in the series, and we're very excited to have you all here today. I'm sure some of you have enjoyed some and learned from some of the previous NBA webinars, and will join us also for those to follow. I've been asked to give a short overview of the NBA before I hand over to Linda, Linda Harris, who is our main speaker for today. So the National Biodiversity Assessment is a large and complex undertaking, and it addresses our mandate to report on the state of biodiversity. It covers many aspects of biodiversity, which include the assessments at the level of ecosystems, species, and genetic diversity. And at the level of ecosystems, we assess all of South Africa's 980 ecosystem types, which includes the terrestrial realm, the vegetation types, the freshwater realm, which is made up of rivers and wetlands, the estuarine realm, where rivers meet the more saline coastal waters, and of course our marine realm that stretches from the shore to 200 nautical miles offshore. And included in the NBA is a cross-realm coastal zone assessment, which is the focus of today's seminar. It includes consideration of the terrestrial, the freshwater, the estuarine, and marine ecosystem components and biodiversity in the transition zone from the land to the sea. Lastly, we also assess our subantarctic territory, which is a substantial marine territory and two small islands that are important from a conservation point of view. And apparently we are the first country to assess all our ecosystem types across all realms using the IUCN's Red List of Ecosystems Threat Assessment framework, which is obviously something to be proud of. Of course, partners are critical for this large body of work. The Institute for Coastal and Marine Research at Nelson Mandela University leads, and represented today by Linda here, leads the coastal component, and the Council of Scientific and Industrial Research leads the estuarine component. In terms of species assessments, SANBI has a long history reaching back for about 40 years, and we're recognized as world leaders in this field. We've applied the IUCN Red List of threatened species categories and criteria to 15 full taxonomic groups, with 3 new groups assessed for the first time in the recent NBA. These were freshwater crabs, fairy shrimps, and spiders. And this is again achieved with multiple partners contributing and leading on this assessment of taxonomic groups, such as the Endangered Wildlife Trust, which leads the Mammal Red List, and BirdLife South Africa that led the bird red listing work. And then, of course, genetic diversity underpins all biological diversity and plays a key role in individual fitness, species ability to adapt to changing environments, and overall ecosystem resilience. Yet indicators for this aspect of biodiversity are being freshly developed, and again we claim to be at the forefront of piloting these indicators and reporting on them in the NBA 2025. So these efforts are based on a wealth of publications and previous resources and result in a range of NBA products. There's a summary of findings and key messages book available for download. And then for the first time, we published the NBA as a website that includes 108 pages with lots of interesting details, images, plots, and maps. So I encourage you to go and investigate those. The NBA format allows us, this new website format allows us to update components of the NBA as updated data or information become available. And our in-the-house data science skills have taken a huge step forwards in the last few years to enable such a living national biodiversity assessment. And this momentum will enable us to improve biodiversity monitoring and reporting systems more broadly than the NBA also. So staying at the forefront of biodiversity assessment and reporting requires constant innovation and problem solving. The NBA is a massive collaborative effort with many South African and international researchers and institutions. And to demonstrate, for the NBA 2025 was a collaborative effort that involved over 490 contributors representing 110 institutions. It took approximately 23,000 person days of work, completed over 6 years. And that's, of course, not counting the many previous NBA-related products and work that was our foundation. It requires a great deal of facilitation from the leadership team and the amazing goodwill and shared interest of our partners in making this useful product and process. The NBA is a product of the whole biodiversity sector of South Africa and deserves huge acknowledgement to all the supporting partners, authors, and coordinators. So I now have the pleasure of handing over to our main speaker today. Linda Harris is a rock star, or perhaps a starfish, in the marine ecology and conservation planning fields in South Africa and internationally. She's currently a research associate at Nelson Mandela University, a Pew Marine Fellow, and a project researcher on the International Convex Seascape Project. And besides her sandy beach ecology outputs, Linda has been at the forefront of marine spatial planning and prioritization work, as well as ecosystem and species assessments. She's been an incredibly valuable she has been an incredibly valuable partner to SANBI and led multiple components in the 2018 NBA. And as in 2018, she again led the coastal assessment for 2025 that we're about to hear about. She supervises a raft of students, has a formidable publication record across high-impact journals, and is extremely dedicated to improving the management and conservation of our coastal and marine seas. So we're very fortunate and thankful to have Linda contributing so strongly to SANBI's work, and I'll hand over to her now to tell us more about the coastal ecosystems and the key pressures they face. Thanks, Linda.
Thanks, Jock, and thanks for that very kind introduction. Just do need to be cognizant of time because this is a jam-packed presentation, so strap in. I'm sure we all are very aware and very blessed to live in South Africa, where we have such a beautiful coastal zone. It really is a national treasure. And this is largely as a result of our unique position at the land sea, or at the southern tip of Africa, where we've got these very strong gradients between our west coast and east coast, along the country's coastline, as a result of our exposure to those three different ocean basins. And this gives rise to a diverse coast in terms of both ecosystem types as well as species, with many of those biodiversity features being endemic to South Africa, which means that we have the sole responsibility for looking after them. And I'm not going to focus on biodiversity today, but if you are interested and you want more details on coastal biodiversity in South Africa, we do have a publication linked to the NBA on that. And it was because of this very important biodiversity and the importance of the coast for South Africa that we started a dedicated cross-realm assessment, because we realized that the pressures that the coast is exposed to was creating slightly different trends, and that were being lost when you looked at the separate terrestrial, estuarine, and marine assessments. And so the bulk of my talk today is based on a publication that I haven't looked at the participant list, but I'm sure that many of the people who contributed to this paper will be on the call, and where we looked and we reviewed coastal pressures in a cross-realm, using a cross-realm lens. And typically when people consider pressures in coastal systems, they might, for example, focus on the landward side, or they may focus on estuaries, or even particular marine systems like perhaps kelp or corals. But what we did is we said, right, let's look at the pressures that are impacting South Africa's coastal zone, because we recognize that it's a holistic system, and things that are happening on land may be influencing estuaries and the ocean and vice versa. And if we look at these things in a compartmental way, we're actually going to miss the coastal picture. So with that in mind, you'll see at the bottom of each of the slides, we rated the pressures, and it's a combination of the severity and extent of the pressures. For the coastal zone as a holistic entity, and then for each of the broad ecosystem groups that are loosely arranged from the most landward to the most seaward sides. So it's got the coastal vegetation, then the estuaries, then the intertidal systems, then the shallow subtidal, and then a little bit further offshore. And obviously then the size and the bubble and the number inside, you may not necessarily see the numbers, I'm not sure, but the size of the bubbles is representing the relative severity of those pressures. So the first one is, like I said, we assessed these in the 10 categories that the IUCN uses for pressures on biodiversity. So the first is biological resource use. This is the highest ranking pressure of all of those that we assessed. And it, as you can see at the bottom there, it is a cross-realm pressure. It's present in every ecosystem group that we have. And this is where harvesting is primarily for human consumption, so for food, but the other uses include bait, animal feed, crafts, construction, ornamental and aquarium trade, culture regalia, and also traditional medicine. So the types of biological resource use that we have, it's on the marine side, we've got the marine fisheries for fish and invertebrates, and there's 16 of the fisheries that interact with the coastal systems. Then in estuaries, we've got recreational and small-scale fishing. On land, there's wildlife hunting, trapping, and poaching. In the intertidal systems, and in the shallow subtidal, we have seaweed harvesting and beach grooming. So beach grooming is where we remove kelp wrack specifically with the purpose of improving tourism, because tourists don't like the smell of the degrading kelp. And then, of course, we have plant collecting and plant poaching, with poaching of succulents, particularly in the Northern Cape, being an escalating problem. So our key issues related to this pressure is obviously the amount of resources that are harvested each year. And then compounding that is the amount of illegal harvesting. And then, of course, there are related issues, including bycatch, when poisons are used to catch animals, and then the risks of invasive species. And it is recognized that this is an increasing pressure along the South African coast. Then in terms of the wind farm, in terms of energy production and mining, there's three main pressures here. So it's mining, petroleum, and renewable energy. In terms of mining, this is a cross-realm pressure, so it impacts the terrestrial, estuarine, and marine systems, and this is where it's extraction of sand, diamonds, and heavy minerals. And as we know, mining is a destructive practice. It causes a lot of habitat degradation and fragmentation. It comes with a lot of pollution, lethal, non-lethal impacts to biota. Also, animal behavior changes. So, for example, where the turbidity changes as a result of mining practices that can change animal behavior. And then, of course, local extirpations, where animals and plants are lost to local areas. And a key concern in particular is the serial mining along the West Coast, where individual mining operations on their own are one thing, but then when you start stacking them up, it's actually it's a substantial portion of the West Coast that's being mined, and that is of concern. Then in terms of petroleum, this is primarily an offshore pressure. It's less directly impacting the coast. And of course, with the increased interest in offshore petroleum as part of the National Development Plan to grow the blue economy, with key issues here also including habitat loss and various forms of pollution. But primarily for the coast, we're looking at mainly the impacts of oil spills, when those spills then impact, and for example, oil seabirds, or they wash up on beaches and on the coastal shores. And in some cases, the toxicity from the dispersants used in the cleanup operations can actually be more toxic for coastal biodiversity than what the actual oil itself is. So this is really something that that can cause quite severe impacts to coastal biodiversity. And then renewable energy. So this is wind, solar, and green fuel, including green hydrogen and green ammonia, and then marine renewable energy as well. We currently have some wind farms near Oyster Bay and Saldanha Bay. There's planned photovoltaic solar plants for Saldanha Bay and Cape Town, and then planned green fuel initiatives for Buku Bay, Saldanha Bay, and Kucha. There's currently not any real marine renewable energies at this point, although this would include things like offshore wind, current, wave, and thermal energy sources. And there are plans for development of this. And in terms of renewable energy, the key issues, again, are habitat loss and changing local habitats, where you maybe potentially change microclimates, or where there's wind turbines, there's a risk of bird collisions and barrack trauma. And then, of course, also the different mining, or the different energy production sources come with different levels of pollution, including noise, brine, and so on. Pollution is a pervasive issue. It predominantly impacts aquatic ecosystems, so the estuaries and marine realm, just because of the nature of the water. And here we're looking at solid waste and plastics, land-based wastewater discharge, with about 655,000 cubic meters of municipal wastewater discharged daily into our estuaries. This can include both chronic and also pulse, releases of wastewater. Then there's light and noise pollution, and of course dumped ammunitions. And there's a range of issues related to this, including entanglement, ingestion, and accumulation in animal tissue, causing gut blockages, for example. There's also changes in water and sediment quality. There's community changes, eutrophication, which can fuel harmful algal blooms, which I'll talk about later. And it can also lead to toxicity, including fish kills. Metals and pharmaceuticals are an increasing problem, and particularly in terms of bioaccumulation, biomagnification, and biotoxicity. Then in terms of light pollution, we've got artificial light at night that disrupts circadian rhythms of animals and animal behavior. And this is particularly a problem in species like Tylos capensis, a beach pillbug, which we'll talk about later. And coastal development and artificial lighttime nights is one of the species that changes its foraging behavior as a result of the light. And other species also, they have similar effects in terms of foraging and breeding, which then can impact those species. And in other parts of the world, they found increases in seabird strandings as a result of artificial light at night. Then in terms of noise pollution, we are experiencing increasing noise levels, particularly underwater noise. And this is causing both lethal and non-lethal impacts to biodiversity, as well as inducing behavior changes. And in terms of dumped ammunition, so this is disposing obsolete munitions in the marine environment, and it was practiced in South Africa from the 1970s until 1995, before the 1996 London Protocol came into effect. And we don't have a lot of a good understanding of what those impacts are, but they have almost certainly started to corrode in the last 30 to 50 years. And so there's a potential for pollution and metal toxicity that elsewhere they're predicting those kinds of impacts will increase with time and climate change. But in South Africa, these impacts are largely unknown. Then in terms of coastal development, so this is construction of buildings, ports, harbors, and other hard infrastructure in the coastal zone. In South Africa, 17% of the coast has development located within 100 meters of the shore. And it's generally the areas that are associated with ports and harbors that are the most intensively developed. And when it comes to coastal development, the key issues are obviously habitat loss and fragmentation, and loss of diversity associated with that, particularly in some of the terrestrial habitat and some of the terrestrial species that have got very small ranges. We also see then interruption of ecological processes as the land-sea connectivity is broken down, which then comes with compromises in resilience. And then also in turn, compromises in ecosystem service capacity and delivery, in particular things like coastal protection services that would have typically been provided by dunes and beaches, for example. And importantly, coastal development is generally an irreversible pressure, it's largely an irreversible pressure, where and in particular we're looking at a quarter of the natural habitat lost in the Indian Ocean coastal belt within the ecologically determined coastal zone as a result of coastal development, and 9% of the estuarine functional zone area. So that is important. And what we've also see is that the amount of coastal development that we have is correlated with the sum of all other pressures to biodiversity. And it's really just talking to that human footprint in coastal systems. Then we have port and harbour activities and shipping. So these are, this is transportation and service corridor. Sorry, there's a mistake on the slide. Anyway, so what we're really looking at here, oh, sorry, my bad. In terms of transportation and service corridors, we have port and harbour activities and shipping. So that's one of the pressures under this topic, where we have chemical pollution, and particularly because ports and harbours are these retentive systems, and so the impacts of pollution are escalated. And we also have noise, and then ship-to-ship bunkering, which is that there's a high risk of oil spills, and we've seen a number of instances, particularly in Algoa Bay, where that's resulted in oiling of penguins and other seabirds, and then also then the noise associated with that is also impacting those birds as well. There's also associated with ports and harbours, we have invasive species and ship strikes, and then the dredging to maintain the channels in those ports and harbours increases turbidity. It can change bathymetry, and then just that cycling of the sediments can start increasing the bioavailability of pollutants that were locked in the sediments. Then we have roads and railway lines, and the key issues with these systems are that, or with this, these structures, is that they break cross-realm connectivity, and that is a key issue and can cause a loss of habitats like mangroves when it severs the connection between the estuaries and the sea. And then we also have cases where bridges over estuaries, they stabilize the dynamic estuarine channels, and it can cause extensive erosion of sediments, particularly during heavy floods. Then in terms of natural systems modifications, we have more than 30% of estuaries in South Africa reduced by freshwater flow. And so that's part of the estuarine hydrological regime change. And then we also have disrupted sediment flow coming from stabilization of sand dunes, and changes in the flows through estuaries, for example, like in the picture of building weirs where there's dams and so on. And what these disruptions in sediment and estuarine flows, what that does is it reduces the amount of sediments and fresh water reaching the marine environments. And that's particularly an issue for beaches and for mud belts. Beaches and dunes, of course, and then for mud belts in the marine environment, and then you also get things like breakwaters, piers, groins, those structures that extend into the marine environment that then change the longshore transport of sediments, and that can cause changes. The changes in estuarine flow can also cause changes in estuarine conditions. So, for example, in Flurin Bay, there's incredibly acidic conditions there. And it can also, the amount of water, if you change it moving through the estuaries, it can also change the mouth dynamics, particularly in those temporary open-closed systems. And in turn, that can compromise life cycles and nursery functions that are provided by estuaries. Then in terms of other forms of natural systems modifications, this time on land, we have livestock grazing and browsing. Generally, rangelands are a biodiversity compatible activity, but it can pose risks to coastal biodiversity. So for example, when livestock they cause trampling in dunes when the cattle are going down to the beaches and to the shores. You can also get increased risk of alien invasive species in areas that are heavily grazed. There's changes in sediment compaction and estuarine bank and can cause estuarine bank erosion. And then, of course, also impacts to estuarine habitats, particularly things like salt marsh and mangroves, where you get stunted mangrove growth as a result of livestock eating those plants. In terms of human intrusion and disturbance, this is primarily the non-extractive human activities in the seashore zone. In other words, focusing specifically on the fore dunes, on the intertidal systems, and in the estuaries. And it's primarily related to recreational activities. And we can see here that the key issues are things like dune trampling and destabilization, and that can lead to blowouts in the dunes, which can then cause erosion and then just compromises the resilience of those dune systems in the coastal zone. You have things like trampling and beach driving, although beach driving has largely been banned, but there are certain cases and places where beach driving is permitted, and this can cause lethal and non-lethal impacts both to the berry biota in the beach and also to things like shorebird nests. Then the recreational activities in the seashore zone, they can also cause changes in foraging and breeding activities, where instead of animals feeding, for example, they're spending more time in vigilance and in flying away and escaping perceived threats. And then in the aquatic system, so in the marine environment and in the estuaries, there's recreational boating, and that can come with pollution, with noise effects, and particularly in the estuaries, it generates waves, which can then promote erosion of estuarine banks and then lead to habitat loss, particularly of habitats like salt marsh and seagrass beds. There's also boat and propeller strikes, and then of course anchor damage in these systems as well. Then in terms of agriculture, aquaculture, and plantation forestry, so starting in the marine environments, the mariculture is aquatic operations that are using long lines, rafts, racks, or cages that are suspended directly in the water, and this is primarily in Saldanha Bay and Algoa Bay, and in a limited number of estuaries. And then there are also land-based operations that abstract seawater. They pass it through a culture facility and then return it to the sea. So this is an increasing pressure in South Africa, recognized as a key growth sector in the blue economy. And there are key issues associated with this, primarily the risk of alien and invasive species, and then the transfer of disease and superbugs that are resistant to antibiotics from the culture facilities into the natural environment, into wild populations. And then in some cases, you can also see changes in apex predator behavior, particularly when it's, for example, fish farms can also cause changes in apex predator behavior. On land, agriculture, so this is things like sugarcane and macadamia nut farms, particularly on the East Coast, and then fruit, vegetables, grain, fodder, vineyards, and so on. Within the coastal zone. So this is caused in, one of the key issues is habitat loss, obviously, because you're taking away natural vegetation for the croplands. And this has caused this, this is removed, well, there's 26% of the ecologically determined coastal zone is under croplands and secondary natural vegetation, and then also 16% of the estuarine functional zones is being taken up by agriculture. And so that is a key issue, and some of the risks then are contaminated agricultural runoff causing pollution and eutrophication, and particularly in the estuarine systems. Then in terms of the plantation forestry, so this is primarily non-indigenous species of pines and eucalyptus. Again, key issues being habitat loss and fragmentation by replacing natural vegetation with these non-indigenous species and monocultures generally, which then also leads to local biodiversity loss. And key issues here is also the impacts that these trees can have on groundwater and associated habitats like wetlands, and their related biota, because those non-indigenous trees, they tend to mine water at much greater depths than the natural species. And particularly in water-stressed environments, this can cause severe impacts on local water resources and the natural vegetation, especially if those plantations start lowering the water table below the rooting depth of those indigenous plants. Then we also see altered understory growth, the changes in leaf litter, changes in soil composition, particularly soil acidity, which in turn then can change nutrients availability for local biodiversity. In terms of invasive species, so on land, what's interesting is that generally there's been deliberate introductions of invasive species, and this is primarily the acacia species, where it's Roycons and Fort Jackson, Acacia cyclops and Acacia saligna. And the issues here related to these, and that was to deliberately stabilize sand dunes in particular, and the headland bypass systems. So that's linking back to the natural systems modifications I spoke about earlier. And here we're generally talking about deliberate introductions with similar impacts. And these deliberate introductions have got similar impacts to forestry, where the natural vegetation is being replaced by these non-indigenous species. And importantly, they can also alter the fire regimes by adding fuel for fires. And I think the Neisner fires that we had some years ago, an alien invasive plants were one of the key factors that was cited in that example, and also reduce mean annual runoff because of how much water a lot of these plants absorb, with an estimation of at least 125 million cubic meters. I think that's annual, but I'll have to double check that. But as a result of these alien invasive plants on land. The aquatic invasions, conversely, is generally an unintentional introduction, and this includes both animal species as well as invasive alien aquatic plants. These alien plants and animals, they impact the indigenous species and the communities, and for the most part, this is a negative impact, where it's the non-indigenous species may outcompete local species. But occasionally you can have positive effects. For example, where it may benefit threatened seabird populations, seabirds and shorebirds, for example. Then in terms of in terms of harmful algal blooms and pathogens and disease, harmful algal blooms, we're seeing increasing episodes of these harmful algal blooms, and it's an increasing pressure, and to be honest, it's likely to get worse, particularly if we combine just coastal population expansion, because a lot of these harmful algal blooms are linked to nutrient loading. So just as human populations increase, and then also with climate change, there's also that plays a role in increasing harmful algal blooms, with key issues being hypoxia, obviously impacts local biodiversity, including mass mortalities. And for example, Donoxera, there was a mass mortality, I can't remember the decade now, but it was some years ago. And then it took that population 14 years to recover from that harmful algal bloom. And then, of course, with potential impacts on human health as well. There's several other pathogens and disease that we're starting to pick up in the coastal zone. So the high pathogenicity avian influenza was detected in 15 species of coastal seabirds in South Africa in 2017. And that was following an outbreak in the commercial poultry and ostrich industry. And then there was a second outbreak in 2021. And then there were sporadic cases that were still continuing in 2023. The water mold, it causes epizootic ulcerative syndrome in fish, and it was first reported in 2011, and it now is found in almost all of South Africa's estuaries. So that's a concern. And then, of course, we've got rabies that we've been picking up in the seals along our coast, and also extending up into Namibia as well. And then finally, climate change. Again, this is a cross-realm pressure. It's impacting the whole coastal zone, particularly the land-sea interface. And of course, here we're looking at things like sea level rise and coastal squeeze. So coastal squeeze being that intersection of coastal development and the combination of that with sea level rise, where you lose those intertidal systems. Increased storminess, rainfall, runoff, and coastal flooding. I think this is very topical at the moment, given the conditions that we've been experiencing in the past 2 weeks. And recently, just, thinking of the KZN floods as well. And then, of course, temperature change and ocean acidification. So some of the key issues we're facing here include habitat loss and fragmentation, and then, of course, loss of diversity. And this is particularly thinking of coastal squeeze, where we're losing those habitats, rain shifts and redistributions. There's flooding risk, of course, for human settlements and infrastructure. It's very raw. We're seeing that as, right at the moment. And then this is, of course, combined with droughts. And so that there's strong concerns for both food and water security. In the marine realm, we're seeing increased upwelling from intensified southeasterly and easterly winds, but then we're also experiencing increased heat waves, both on land and the sea. And if you've got a case where you've got a marine heat wave and upwelling that follow each other, this can cause additional thermal shock for many of those marine communities. And then in terms of ocean acidification, things are variable. And what may happen is that we have microhabitats that can serve as refugia. So, for example, some of the macroalgal habitats seem to have a higher pH, and this may buffer some species and communities from the effects of ocean acidification. So if we put all of those things together, yes, the South African coastal zone is a national treasure, but it's under pressure. And if we look across those 10 categories of pressures, we can see that they're operating cross-realm for the most part. Things that are happening on land are influencing things in the sea, and vice versa. And then, of course, with the estuaries connecting them as well. And so if we then look at how what the trends are in the coast compared to the non-coastal land and sea areas, what we see is that we've got twice the amount and rate of habitat loss. We've got 5 times proportionately, we've got 5 times more mining, 3 times more development and plantations, and 50% more agriculture in the coastal zone. So it's an incredibly intensively used and quite heavily impacted zone in South Africa, which is exactly why we introduced this coast assessment, was to make sure that we were keeping up with the trends. So in terms of ecological condition, then of course the half of South African coast is in a modified state because of all the pressures we've just been through, and a quarter of it is severely to critically modified. And then it's twice the amount of natural habitat that has been modified in the coastal zone compared to the non-coastal areas. In terms then of ecosystem threat status, we then see that 71% of the 190 coastal ecosystem types are threatened, and in terms of types, and then in terms of the coastal extent, it's half the extent that is threatened. And we have 3 times more ecosystem types and 8 times more area that are threatened in the coastal zone compared to the rest of the land and sea. And just pointing out the estuaries, just how threatened they are, and that was covered in Laura's talk last week. So if you missed that, go and look for the recording online on the YouTube channel. We also then assessed beach species for their threat status for the first time. This was a global first. And what we found is that there were 20% of the 20 species that we assessed, 20% was endangered, 15% were near threatened, and then the rest were least concern. And it was primarily that interaction of the land-sea pressures, so things like coastal development, artificial nighttime lights, and so on, and rack management that was driving a lot of the beach species threat status. So all of this has been quite sad up until this point. However, if we then look at ecosystem protection levels, we're actually doing quite well. So although the coast is intensively used, we are making very good progress in terms of protecting coastal biodiversity, with just more than a third of the ecosystem types being well protected, and then 7% of the coastal extent being well protected as well. And overall, we still have just over a quarter of our ecosystem types that are not protected, and 25% of the coast extent is not protected. So although we're making very good progress, we do need to strengthen this, both in terms of adding additional protection, but also in terms of rehabilitating those areas that are under protection, that are exposed to pressures and then are a bit degraded. So the other thing that we can take home from this is that the coast requires careful cross-realm management, and this is going to be critical for securing our coastal biodiversity. And we've written a paper recently on this, and yeah, I encourage you to go and have a look at the recommendations that are in there for how we can improve coastal management by taking this cross-realm perspective. I would now like to hand back to Jock, and thank you very much for sitting through this presentation. I appreciate it. Thanks.
Great. Thank you so much, Linda, for that very insightful talk. I hope you can see all the applause and thumbs up coming your way there. We have a few minutes for any key questions or comments from the audience. And while you're thinking about that, I should add that each NBAA builds on and contributes to a body of knowledge which informs a multitude of policy responses and management actions, which really seek to benefit biodiversity and all of us, the people that rely on a healthy natural environment. Does anyone have a question to raise? Put your hand up. I'm just having a look in the chat. Someone's got their hand up. Marlene, yes, Marlene, please go ahead.
Thanks so much. And I'm sorry I did miss part of the presentation, but the last few slides I think were particularly telling in terms of our progress with improved protection status of ecosystem, yet the trends and the trajectory of all the other indicators show a decline. Many of them show a decline. And this is actually not just in the coastal zone, it's actually reflected across all our ecosystem types if you look at the global assessments as well. So I'd be interested in your views on that, in terms of, is it a case that the existing ecosystems formally protected, are not properly managed? What would you feel is the major contributing factor towards that interesting dynamic? Thanks.
Thanks. It's a really great question, and I think it's something that we really are going to have to grapple with. I think it's a combination of things. I think where we've got coastal protection, depending on what the system is, it can exclude pressures, and in which case it means that the pressures are increasing outside of the protected areas, and then the protected areas are doing a good job. The other cases, and I'm thinking specifically now in terms of the estuaries, for example, where there may be increases in illegal gill netting or activities that are happening either within the systems or upstream, that are then, although the pressures are originating outside of where the area is protected, the effect of that is then moving through into the system. So let's think of like a pollution event that happens upstream of the estuary and then impacts within the actual estuary itself. So we do take ecological condition into account when we look at the ecosystem protection levels, and there is a certain threshold that you have to meet, and it differs for different realms. So you'd have to go and look at the details for that on the NBA website. But we do take the condition of the ecosystem types as a generalization into account when we look at the protection level. So when we say something is well protected, it generally means that it's areas that are in good ecological condition and are meeting targets. So I think, yeah, so to answer your question, broadly speaking, I think there's a combination of things going on, and it's going to depend whether you're a terrestrial or marine system, whether the pressures are originating inside or outside of the protected areas. Some things are going to be difficult, so like an invasive species. In terms of aquatic invasions, I think we're now realizing that it's incredibly difficult to eradicate an aquatic invasion, and that prevention is better than cure. So yeah, so I think it's a range of things, but it certainly is something to be cognizant of, and that just because it's a protected area, that in and of itself does not mean protection. It's really about then maintaining and ideally improving the condition of those constituent ecosystem types within it. And yeah, perhaps if there's any other questions, just while we're waiting. So just to note that the coast content for the NBA, we do have the website content, and it's intended to serve a broad audience, but there's also a series of publications, as you would have seen in the presentation, that I referred to some of them. So please do, particularly for the scientists on the call, just go and have a look on the overview page at the bottom. There's a summary of all the papers that are linked to the NBA, with the precious paper due to come out in the next issue of African Journal of Marine Science. I don't know if anyone else has a question. No? The coastal priority mapping shapefile, it is available if you go to the, if you click on the link on the paper, it's on the website. The paper is on the website. There's the shapefiles are downloadable. They're stored in Figshare, so they are available. Okay. Right. Jock, I don't know if you want to close the meeting.
Sorry, I've been speaking and I've not been muted. Thanks, Linda. Yeah, so are there any other further questions before we close this seminar? I don't see any other hands raised. We are pretty much on time. So thank you again. Many thanks to Linda and everyone for attending. A reminder that this recording, that there was a recording and that it should be made available on our YouTube channel if anyone wants to take a second look or share with colleagues. And again, a reminder to have a look at the website. All right. Thank you very much. Thank you very much, everyone, and take care.
Thanks, everyone. Bye.
Thank you.
Thanks, bye.